I see the code. I don't
We
see it.
are live. I
Yay!
think people can see us, right?
Oh, let me turn down my audio.
Hello.
Hi,
Hello,
everyone.
everybody.
Good morning, good afternoon, good evening, and maybe good middle of the night to somebody.
Depending on where you're tuning in from.
Yeah.
Welcome,
Okay.
welcome. Yeah.
Hola. Hola, Mario. Hello,
Oh,
everybody.
yeah,
We're
it's
so
very
happy
early
to
for
see
Mario.
you.
Yeah, it's so nice to be back.
Hope that everybody enjoyed their summer. It was
And the
a
sound is
long
good.
break for us.
We're seeing a good sound. We
Exactly.
already got one. Thank
But
you. Oh, my mic is good today. I put it in the right place. We
was
tested
just
it
about
midweek, and it wasn't great.
I was
My
just
mic
about
is
to
kind of
ask.
made invisible by the background removal, but
But everyone can hear everyone, yes?
yes.
Yeah, I wanted to
Awesome.
ask that. Can you tell us, Chad, if the three of us are our sound levels good enough? Otherwise, I need to tweak. Yeah, perfect. Yeah.
Mario says all good. Amazing. Wow, on the first try. I think we're rolling into season 2 nearly on time and with good sound. Things are looking good.
We did practice this
Amazing.
time, though, so
We did.
it
It's
was
true.
totally worth to
Yeah.
come here during the week secretly to practice our sound and video.
I think,
So
well, not so secretly. Some people thought we were streaming a secret, a surprise guest stream on Wednesday evening.
maybe
but
one
no.
day.
Yeah.
Maybe one day. So today we have the fabulous Dan
The man,
Shiffman.
yeah. Dan the man. He needs no introduction.
Yeah,
But we will introduce him anyways.
we're so excited. I'm
So
gonna
excited.
go first and say it, and then you can
Go for it.
tell your story, Eliza. That
Yeah.
I have to tell you that I learned creative coding with you and 𝗶5 like 2 years ago. I didn't know about
Oh,
the
wow.
existence of creative coding. Like I've been working as a developer before, but I wasn't into creative coding like with JavaScript, and then I found about it from a friend, and then I found you on YouTube, and I loved it. I enjoy your teaching, so it's wonderful now to get to meet you.
Thank you. That's
some
amazing to
sparkles and
hear.
some confetti your way. Well, I'm sure you know that you inspire so many people. I don't know if you remember actually years ago the Mindstorms book club thing.
Yes,
So
of
maybe
course.
I've already told you this, but you are the one who made me realize that I wasn't not a math person. So it was really cool. I loved creative coding and was very scared of the math, and so I wrote my thesis about it, but was too scared to even try for like years. And finally, I dove in around 2015 and found your Nature of Code on Cadenza, and I don't know if that's how you pronounce that platform. I think
so.
Okay, cool. Yeah, and then I was like, oh wow, I understand things that I never understood in high school, like at all. So yeah,
That's great, because
really cool.
that was really probably one of the primary goal of that project for me was, I had always loved and been interested in math, but I think I was kind of, in many ways, the kind of person who was just sort of told you're good at math, and not everybody has that experience for sure. But I didn't really discover, I think I discovered when I started to like code that there was this nice meeting that had suddenly happened of being able to explore these ideas in a less abstract way.
Totally.
And the goal of like putting that book together was to help unlock that for other people. So one person is enough. So that's great. I think it's maybe I'm up to like maybe double digits, but
yeah. But speaking of, you said before we went live that you started coding, and I knew this, but you started coding when you were 28, which is when I started coding.
Tell us.
I love that.
Yeah,
awesome.
me too.
Yeah,
actually.
so
I felt that it was late, but it's good to hear other people.
Yeah.
Yeah, so
yeah, and so it's definitely true that I started coding when I was 28. I had a couple experiences. Like I grew up in the 1980s, and I remember my family had an Apple II Plus, which I'm trying to get my hands. It's in my parents' attic in Baltimore City. I'm planning to get it and try to like get it running and see if I can like get the output to live stream. So coming soon someday.
That would be so amazing.
But so when I was in second or third grade, I remember doing a little bit of basic programming for like a science fair project. But that was like, maybe a couple weeks. And then I think I took one like class in middle school where I was taught assembly language, if you can believe that. Or maybe it was ninth. It might have been ninth grade. I also took, after I graduated from college, a like C programming continuing ed class. but I was like, oh, maybe I'll like programming. And I was just like, nah, never mind.
Yeah.
And so at the time when I was doing that, I've been living in New York City after I graduated from college. I was like working in like theater, and like I worked for some music companies. I'm thank you for indulging me and letting me to tell this like life
Oh no,
story.
we want to hear all of
that
this
was the
theater.
intention.
I had no idea about the theater thing.
I
That's
mean,
wild.
I wanted to ask, what did you do in the music?
Yeah.
Sorry, company that you.
I worked for a long time as like, I started as like an office assistant basically for the Leonard Bernstein office. Leonard Bernstein is world famous conductor and composer of like the musical West Side Story, is probably been most famously known for.
Yeah, I heard of that.
And so I just like worked on a lot of like, as like an office assistant, like post graduating from college, and then I kind of started to do more things with them. It's so long ago now, I'm not sure I remember what I did exactly, but I was also like their computer person. So one of the things that I was doing was working as a like freelance, I don't know what to call it, computer consultant, networking setup person. Like, this is in like the late 90s, between like 95 and 2000. So there were a lot of, I remember I worked for this one company that was like a high-end like paint mixing company for like, very fancy people's like renovations. And they were like a custom paint mixing color company in like somewhere, I think they were in like the West Village or something. Anyway, but they were like a small company with like 4 or 5 people. They didn't know how to set up a printer or a network. And so that was the kind of thing that I would do as like a freelancer. And then in the evenings, I was like, I kind of was doing some like assistant directing on like theater projects. Or I started a theater company actually with some friends. And like, I was kind of doing all this stuff. And I felt like, I think I could probably reverse engineer the story as if I had some real intention. But I think the reality is I was like, I think I probably should just go back to school. That's what I'm supposed to do. And so I went to this, I found this program at Tisch, which is where I work now. And I've sort of been there ever since. I started there as a student in 2001, which is why I'm sort of talking about 20 years. And it's called ITP. At that program, I took a course called Introduction to Computational Media. And it was taught with Macromedia Director and the Lingo programming language.
Wow.
And that's where that's where it really took all of a sudden. I was like, because I was kind of going there like, maybe I want to do something in storytelling or entertainment, but with technology. I like computers. I'm kind of into math, from like a while ago. That's why I majored in math when I was in college. So,
oh wow. Okay.
That's why your math, I must say the way that you explain math is it's very good. And
like, it's definitely seeped into it's part of who you are.
Yeah, it's very easy for you to kind of transmit it there. So continue.
Yeah. So I thought ITP might be a place where it would all come together. And I guess in a way, maybe it did. Although I think what I discovered there that I didn't realize is that I really just liked programming for programming's sake. Like I sort of tell people, I think my philosophy or point of view is like, oh, learning to code is about like learning this new skill and this new set of tools to apply to your passion, whether that's, dance, biology, economics, could be computer science, it could be art, all of these fields. But I kind of just like the solving of puzzles and programming. And then I did definitely, when I was a student and a little bit after I graduated, try making my own sort of, generative art pieces, maybe, if you will. But mostly I just like really liked helping and teaching. And that's what I just kept doing. And it was at that time, like right when I graduated from this master's program, it was a 2 years master's program in 2003. That's when I discovered processing. So some folk, different people, JT Nimoy and Amit Pataru, to name a couple, had been teaching with processing.
It was just getting started, right? Like
it was
that time,
super new. I mean, did you start with that design by numbers at all, or did you do?
I didn't. So, one of the things, if some of this is sort of fresh, not fresh in my memory, but fresh in my mind, because it was just the 20th anniversary of processing, and there were a lot of sessions. Actually, there was one with Casey Reese and Ben Fry on like the Art Blocks Twitch, maybe, that you could probably go back and find, where they talked a lot about that sort of like starting history, but I was not involved at all. I happened to be a graduate student learning Macromedia Director at the same time that they were, releasing the first version of processing, but I had no awareness of that.
Wow.
And that Macromedia Director is related, but the lineage of processing is much more closely directly from Design by, it's taking John Midas' Design by Numbers and turning it up to 11, so to speak.
Well, cie Reyes, I believe, and Ben Fry, they used to work with John, no? So that's the story.
They were his
Correct.
students,
So
no?
they were his students in
That's
the
how
aesthetics and computation
the
group.
connection.
Yeah. But I discovered processing through other people who had brought it as workshops at ITP, and then I was like excited to try it, and then I don't remember whether I proposed this or somebody asked me to do this, but it ended up taking over, replacing Macromedia Director as the sort of primary language for our intro coding curriculum, which I think is how I kind of ended up like having a job there, because I was kind of I was like the person who knew processing because I was learning it. Incidentally, John Henry Thompson, who was the inventor of the Lingo programming language, he once did a guest video on my YouTube channel, but he is now back and teaching Introduction to Computational Media with P5JS at ITP. And I get to see him. He's a real, if people aren't familiar with his work, you can look up John Henry Thompson.
What a full
Lingo.
circle moment. That's amazing.
He's really pretty incredible. So that's anyway, so that's where I started. That first course I had maybe dabbled, but that's where like I could trace back to like I was learning to program, graphics and animations in Macromedia Director and kind of never looked back. And I was 28. Yes, that was the point of the question.
So cool. But wait, so you did all of this stuff and you were playing in code and enjoying solving all these problems, and in all of this time you've never poked at a shader.
Yay.
So what?
How
I don't know.
Did you not get there? Because it's all math. I'm so
I know.
curious.
I don't know. It's like I have a little bit of a mental block with some things.
You seem so unintimidated by literally any topic.
I know, right? And yet here I sit looking at the like template shader code in the HTML file that you have set up, and I feel somewhat intimidated by it.
No panic.
No.
You'll see once we explain the basics, you're going to be like, wow, this is so simple.
I would say that I have a loose conceptual understanding of the graphics pipeline. I have clicked on the Book of Shaders link many a time to be like, oh, let me like go through this a little bit. I've referenced it many times. And I've actually helped students with their shader code before. Because,
I fear because
why not? Like I can kind of look at it and see like, but I have never start to finish like coded my own shader or really taken the time to really like understand the terminology in any way beyond like a very superficial. And I think one of the things that really greatly confuses me, I'll start with a question, which is, I mean, we could go back to like informal chatting about history of creative coding too.
We can jump
but
in
one of the things that I feel like I'm always wondering about shaders is I understand that there's an aspect of writing shaders, which is like coding an algorithm for an individual pixel. And then that kind of explodes out to all the pixels and it happens in parallel very, very fast.
Yes.
Is that kind of
exactly?
But then there are like these other things where you're writing a shader that's like, is it like that creates geometry? And then is that like, that's where I'm like lost. Like I don't understand where the leap from that one step further. And the other thing I should say is both of my kids love video games, but in particular, my son who plays a lot of Minecraft is always like downloading all of these mods and add-ons and shaders. So I was talking about, I got this new shader for
Minecraft shaders are impressive. Yeah.
So I feel like I should really learn this stuff. One is like, I got to have something new to teach at some point. Like I kind of done all my old tricks too many times. So maybe I could make some shader tutorials if I learn it.
Oh my goodness.
And also like, it would be fun to sort of like, if there was some way this knowledge could seep into my video game playing with my kids. So
definitely, I was gonna suggest that too, that you can learn with your kids, kind of, because it blends in. I mean, it's there's a broad usage on video gaming, I believe. With the shaders. So So first of all, since we figured since you're new to it, today we are gonna like touch on some basics. And especially because sometimes we have viewers that maybe might have not been here. Maybe it's the first time that they're tuning in, and maybe as well, just like you, they haven't poked at shaders yet. So
it's a great way to start the second season. We're going to do a great review by teaching you about shaders. Also, though, we're going to do a fragment shader specifically. Okay. There's like all kinds of different types of shaders. And so we're going to stick to fragment, which is like the colors of the pixels. And so that's going to answer your question about like, how do we make shapes? We're going to make one shape. Well, because what you had suggested when we talked, right, was like, let's take something that you've done on codingtrain and reproduce it as a shader. Yeah. And so one of my favorite videos of yours is the one with the golden ratio, the Phyllotaxis pattern.
Oh, cool. Perfect.
And so we're going to do that, and it involves creating one shape. It's going to be a sphere, and we're going to make a bunch of them, and then we're going to create that pattern. So you'll be able to like find your bearings in there because you know this code. It is your code. Plus it's shaders.
Except, like, I have to say, like, I probably should have looked at it fresh. I mean, I remember the Phyllotaxis pattern, and I think but it wouldn't hurt to
with your favorite number. I think you said in the video is like your favorite ratio or something, 137.5.
Yeah, I tend to just say everything is my favorite. I'm very enthusiastic about too many things. So, but yes, I'll stand behind that statement. That's my favorite ratio.
Well, before we dive in anyways, let's go through like what this CodePen even is. Because you were, for example, you were poking around in the JavaScript before, which is basically
the template on the chat, by the way, because some people said that they wanted to like maybe follow us. So, for example, if everybody goes to that link of the book of shaders, that's where they show how to run the shader with JavaScript, like we're doing with 3JS.
Yeah. So to get shaders, you can do shaders in the browser a few different ways, but we use the 3JS basic scene just because it's like one of the easiest ways to do it. So the whole scene in JavaScript is just like a very basic 3JS scene setup that isn't so important for us right now. But as you can see, there's like a plane in there. And so what we're putting the shader on is the plane because you're putting the shader on a mesh always.
By the way, quick question. 3JS you've used, right? Even when you
yes, very little. I tend but yes, I have used it a little bit.
Well, it is the same concept as in P5 actually, because I was using that before to do shaders on my website.
Right.
And yeah, you've done WebGL in P5, so it's the same.
Yes. Yeah, and that's what I thought. I was supposed to live stream yesterday, but schedule got sort of out of whack. So I'm planning hopefully to do my own live stream this Monday. I had this thing that I want to do, which is, I'm sorry to like go off on a tangent here, which is to try to make try to build a simple auto encoder, which is kind of like a machine learning model for training a sort of very basic generative machine learning model that you can generate images with. But we'll see. Maybe I'll try to dabble. Maybe I'll dabble with. Okay, maybe I'll dabble with some shaders on a future live stream. But I was like excited to try exploring it with P5. So,
I'm in the process of making a new website, and my like experiments tab pages are going to be shaders, but in P5.
Cool.
Yeah. Okay, so what else can I say about this template? So we put it on a plane, and then you can ignore the CSS because that's just very basic stuff. And then we pop into the HTML, where you see the vertex information, which we don't really need to talk about because we're not going to use it today. But basically, in the fragment shader area, in the main function, that's where we're going to be working. We might define a function outside of it, but I don't think so, Ilithya. Are we? No.
But maybe just so, because you asked this earlier, Dan. So the vertex shader is the one that is used when you want to tweak the geometry of the shape.
Got it.
So if you wanted to make the plane wiggle or something.
Exactly. So when you want to manipulate the shape, it's better to do it through the vertex instead of the fragment, because the fragment, let's say, is the pixels and the vertex is the geometry. So.
And in fact, the way that we get the position of every pixel in the fragment is via the vertex shader, which is why it's in there.
Got it. So a shader is a way let me try to start over here. A shader is a way of writing an algorithm for a particular piece of geometry. And the sort of like most basic version of that would be a flat plane.
Yeah, of two triangles, basically.
Two triangles. The fragment shader allows you to manipulate the individual pixels of the sort of like texture, the colors, right? And then the vertex shader. So if you were making a
manipulates the position, of the pixels on the triangles. Yeah.
So if I were doing a particle system, I potentially could have like a shader for like the animated texture of an individual particle. That would be the fragment shader, and then I'd have vertex shaders moving them all around.
Yes, but then I'd say also if you wanted to do particles, you'd probably want to use compute shaders, but that's like a whole
compute shaders. Yes, I've heard that. Yes. Okay.
Right. Totally like.
I know what I'm doing for the next 20 years now.
Yeah.
Okay.
Yes. But you're like compute shaders are like shaders times a million. Right. So it's like it's a wonderful rabbit hole.
Got it. Okay. I think I have a better picture in my mind now of what's going on here. Great.
Yeah.
Okay. Do you want to talk about the HTML file, Ilithya? Is there anything else you want to add to it?
Well,
we have.
I think I can show the CSS because I didn't show it when you were mentioning it, but it's very basic, so there's nothing big on it, because basically we're focusing on that. And maybe another thing to point out is that sometimes since when you want to compile or render the shaders in the browser and you're using most likely 3ES or P5, you could write the vertex and fragment shader in the JavaScript as well.
Got it.
In P5, I tend to do that.
Yeah, it's a matter of taste, but I prefer when we are here, I think it's more readable to do it because when you do it in the JavaScript, it's kind of like a string. So then when, like a string, you don't read the colors of the code. So then it's a little bit harder.
It's harder to debug. Yeah.
Exactly. So that's why we come and write it in here, because then we kind of like, it's more
Got
readable.
it.
And the only other thing I think I would say that's probably good to know is just in the fragment shader script part, you'll see that there are these two uniforms. And so uniforms is information that we're bringing into the shader from outside. Right. So like
that's the one thing I was kind of aware of, because when I've helped people with their code, I've always seen this, like I've always sort of like it's often in the context of like they found a shader, but they're not really writing their own shader, and they brought it in and are trying to figure out how to manipulate it with their, say, P5 or other code. And there's typically like, if I'm right, like a set uniform, it's a way of sort of like passing a value. It's kind of like an argument to the shader in a way.
Yeah, exactly. Like so in the JavaScript, you'll see there's, if you look in the geometry 3-plane buffer right underneath, there's a uniforms object, and you get time and resolution.
Got it. And so if I wanted to pass like mouse
also works. Mouse works.
That would be the way of doing that.
You could send in, I've sent in like audio before. You could really send in tracking device, positions or whatever, tracking positions. Wow. Yeah.
It's very useful when you want to manipulate something through JavaScript, like through the shader, right? So because then if you change it, like the mouse position or anything else that you want interactivity, then you do it in the JavaScript and it will update the shader if it's already as a uniform there. So
I've seen people do it with the leap as well, the leap motion. Yeah, lots of fun. And the MIDI, I've done it with the MIDI controller. It's a bit hacky if you do it on the web, but it's doable. Okay. So
I have to say that I'm just so happy to see so many people in the chat. Just one more time, like Flopin is here, Bruno's here.
Yeah, so many of the lovely people we had last season came to say hi.
I think you're always in our stream as well. So it's just very lovely.
Thanks everyone for coming. Computational Mama.
Yeah, I'm seeing some familiar names there as well.
Yeah.
Yes. Everyone should check out Computational Mama's YouTube channel, or maybe Computational Mama is also on Twitch. I'm not sure.
She's on Twitch too. That's
Twitch too. Great.
That's where I watch you.
Got it.
I believe, if I'm not wrong. Yes, she said yes, I think. Or she's just happy that we're saying hello as well.
Oh, Ophelia too. Awesome. Yeah, she's on Twitch. Okay.
Great.
Okay, so shall we? What were you about to say something, Alethea?
No.
Okay.
We can just.
Shall we explain okay, so we have time in our main function, we have time, but at the very top we have UVs. And so UVs are basically XY. I don't know if you've heard that story, but XY was taken. So in shaders, we call them UVs, but it's pixel position.
I'm familiar with UV as the sort of coordinates when you're texture mapping something. So you have the XY pixel, and then you're taking the UV coordinate from an image. So yes, I am familiar with UVs.
Perfect. So that's,
Okay.
And then we have this everything that comes after the UV is basically setting the stage in our shader so that if we resize our screen, it stays in the center. So this is the uresolution.yy. That whole thing is just a little hack that we discovered last season that now we use every time. And then we've got, so float time is our uniform.
Wait, so wait. So first of all, those are vectors. So, and you can use just plain operators with vectors. Like you can take it like a vector and add, subtract just with the plus and minus operator.
Yeah.
But what I missed there was like, so I understand what the fragment coordinate would be as an XY. And then resolution, half the resolution is like half the width or the height?
Yeah, so that's centering it.
That's centering it. And then what's the YY?
So that's the hacky part. I don't know. Ilithya might know those details. She's the one who found that one. But somehow it makes it responsive.
Oh, I see what you mean.
Yeah.
Because so I don't know what it is, but you're sort of dividing by some scale factor.
Yeah.
Yeah. And I wanted to maybe comment that because we can still like, where is it? I'm searching.
Is it / as a comment?
Yeah.
Yeah. You can continue. I mean, while I search something, explaining the color, how the color works.
So shaders is a typed language, right? So we use vectors as containers for our information. And so what in fragment shaders, you give it a position, you give your shader program a position and you get back a color. And so we set a base color here as black and we feed it into this line here. Is GLFrag color will always be a vector 4. We're in 2D land, so we are only really going to use like XY to influence things because we're not doing like rim arching or anything today. But so if I were to do like 1, now every pixel on the screen is painted in one shot. So
first of all, GLFrag color is like kind of like a built-in variable. Basically, you're like setting the color of that particular location.
Yeah, exactly.
XY. Yeah. And then is that transparency that you're adding a 4th?
That's alpha. Yeah.
Alpha. Okay.
Yeah.
So why I don't know why I'm asking this very silly question, but why not just have that be part of the color?
You could. Okay, you could do a vector.
It's just you sort of know nothing's going to be transparent, so you can just by default. Got it.
And actually, at the moment, and we will show you when we put like some other color rather than black. If you tweak the alpha right now and make it like, I don't know, 0.5, we still won't be able to see that it's actually transparent because we are not applying the usage. That's why often in many shaders here or even in Shader Toy, you would see the alpha at the very end because especially if you're working only like with the fragment, that you're not like overlapping maybe 2 shaders to actually work with transparency. And maybe to know that the way that the fragment shader always ends inside this void main function, where you write your code, is that the GLFrag color is where you always will have to output the result of whatever you would do in those 4 vectors.
Got it.
And so basically, before I continue, we have a request from the chat. Tim saying, Ilithya, you're quite quiet.
Oh, okay. Really? Good that you said so.
But so in the code right now, when we put GLFrag color as, 0, 0, 0, that vector 3 being color, you're painting all the pixels the same color. So if I were to say in this vector 3, if you just put 0, it's assuming that for each spot it's 0, right? So what if we did like uv.x and then uv.y?
So like the for loop, the
then you
nested
get
for loop
color.
that's in every that's like in 90% of the videos that I make, it's just like assumed.
Yeah, basically. Well, because so there's this wonderful video, I can send it to you on the Discord later if you want, that's from like a couple years ago, of this guy who rolls out a paint gun onto a stage and he does a smiley face really slowly. And that's the for loop, right? It's shooting one dot at a time around a circle, and it takes like 5 minutes. And then he rolls out this like hydraulic gun with like millions of paintballs in it, and he like shoots in one shot the Mona Lisa on a wall, and that's shaders.
Right, because it's all happening in parallel on the graphics hardware. Amazing.
Yeah. Okay, so now,
and is there a random function like built in?
No, you have to create.
Like, no, it's true. We always write our own. What am I saying?
Yeah, exactly. There's like a few, but most of them we have to bring them in order to use them. So that's the difference, like I guess, from using P5 or something that has already built-in functions, right? And here we would need to bring them in. And I found what I wanted to explain to you, because you were asking this before about the UV. So
got it. Yeah.
Normally in a lot of shaders, you might only see that we need this frag chord that is coming from the GLSL, and then you have to, in order to get the UV, get the resolution that you're bringing from, like in this case, in 3S, right? So
yes.
And that's how you can like set up like the easiest way to default the UV. But and we can keep it for like this for now. But when we add something,
you do see it illustrated quite nicely with the colors, because now you don't have the big black square in the center.
Right.
Exactly. Yeah. Because that's why I was gonna say we could keep it like that. But then, for example, if you add a circle or a square,
then it would
and
be
then you
oval.
resize the browser, is when you start seeing, why is it my shader distorted? And
it's gonna look so weird.
Yeah, I got it.
But with colors, it's fine. So.
But yes, I see this is like a good, this line here is it's friendlier to the like, I just starting on the first day here. It's exactly the sort of XY according to the XY, the XY position according to the XY resolution.
Yeah, that's the one from the book of shaders, by the way. So if somebody took the top from the template, that's what you would do.
Yeah. And this is basically C code syntax, is that correct?
Yeah, I was going to say, when you were saying that you did that C course, that maybe this will be very...
I actually, one of the things I did before I discovered processing was, after Macromedia Director, I was mostly doing stuff in like C++. So like I am comfortable and familiar with this syntax. But one thing, so if we were to make a syntax error, like if I were to forget this comma here, is this stuff going to show up in the JavaScript console in any meaningful way, or no?
Not really. It's very ugly. You can open the console if you want,
it does show.
You get a really big,
You have
ugly...
a console on CodePen, and it does show.
Yeah, I see it.
But it's a little bit hard to read. Like if you're new to it, and you might be overwhelmed by all the other errors that you see. But it's like you do see it appearing.
Yeah, and this reminds me of, like, I work a lot with TensorFlow.js and this library called ML5, which is built on top of it. And
I just
you'll get these.
Last week.
Yeah,
I teach that to some students sometimes.
Oh, awesome! Well, it's very common when working with it to get these sort of like insane error messages about like shape mismatch error, like expected, this, so like that are all like in the sort of like lower level. Because actually it's interesting, there's quite a correlation here, because TensorFlow.js uses the WebGL engine to do all the matrix math that is behind machine learning neural network based machine learning algorithms. Anyway, it's all the same kind of idea.
Yeah, it is.
Okay,
all right,
so let me just check the chat briefly. Everyone's excited.
Is the sound level better, by the way, for everybody?
I think so. No one has said anything yet since. Okay. So I think it's good. Okay, so now that we get what the pixels are, let's make one giant sphere.
Okay.
So by the way, Dan, did you get that, like with the color that was RGB, if you have like a favorite color, like, I don't know, blue and you know the actual percentage of the red-green values, you will type it in here, but as a floating number instead. So 100% would be like 1.0 and so on and so forth.
That's my favorite way to deal with color. I like everything normalized between 0 and 1. It's a very comfortable place to be.
Okay, great. Yeah. But yeah, let's try to add a shape now so that you can see how we will manipulate this space in order to bring something. Should I go ahead and...
Yeah, go for it.
As we can say like...
Or wait, let's do a basic step function first. Just to see, before we do this, yeah, let's just do that first, just for fun. Float, what do I want to call it? We'll call it a line equals step. So a step function tests the position of a pixel against a position that you give it. So if I do like UVX, I might be doing it in the wrong order. And then how do I show it again? Suddenly I'm blanking.
I think it's
I have to add it to, oh no, I did it in the wrong direction. But where do I add it to get it to show? Do I just add it to color?
And I think it's the other way.
Yeah, uv.x, and then I do color plus equals line. Yeah, so now the program is basically saying where is uv.x in relation to 0.5, and if it's to the left, it's going to paint a color, and if it's not, you just get a 1, which is a white.
So line is a so
let me do it with black and white. It's easier that way. Yeah.
I understand the concept. I'm just trying to figure out like what is actually the math that puts the value in line. Is it as simple as like the absolute value of
comparing
minus 0.5?
Step is basically comparing two values.
Oh, does
step
it give you a
like
Boolean?
an integrated.
It's kind of like an if. An if.
If it's bigger than 0.5, then x is going to be 1, and if it's less, then it's 0, and there's no in between.
Gotcha.
But then if you want there to be an in between.
So you could have done this just as color equals vec2. Whoops, I did this wrong. Like this would also work.
I think you'd have to do this.
Vec3.
Yeah, exactly,
that's
vec3. Because
it's a color, yes, of course.
Yeah, of course.
But that didn't.
But then
but because there's an extra 0.5 there.
Yeah, I was just transferring it into a smooth
step. I think both of you are
step.
moving, so maybe that's why.
Yeah, let me put it back to a step so that Dan can intuit.
Yeah.
Yeah.
And so if I did this, like, you would get full. Got it. Yeah. Okay. And I could do like and then smooth step. You're saying would give you.
Smooth step is what would make it into like a bit of a gradient, so you can like smooth out the line a little bit. But for some reason, here it does nothing. Maybe I did not do I always mix up the order of the things.
So is there a reason why I wouldn't just do something like...
A smooth step is like the name is saying, is kind of smoothens up the edges. So instead of being so sharp, because as you notice right now, step, it's a very sharp line. So if you would like to blur that line, then...
So this worked. My weird idea worked.
Yeah.
Yeah, exactly.
But I did it backwards.
No, you just did it differently.
Yeah, okay.
Yeah.
I was trying to get it to be bright in the center, but I'd have to do it this.
Yeah, exactly.
Yeah, I mean, I knew you were going to be like...
I think you need a
missing
dot.
the floating number.
Oh, you
sometimes
need
shaders could be a little bit
there we go.
Yeah, there we
go. If you're
go.
using floating, it's asking for floatings. You can see it's quite like super thin in there.
Yeah. Cool. And I could have a global variable that's like cycling through. Like if you would do like, and then if just like doing weird stuff here.
Just give it a try.
Maybe
I think we might need to use isn't it const when it's
Uh,
outside?
Mm,
An
no,
int?
because then it wouldn't change.
This? No.
But I don't think that. So the reason that in shaders, when we do the Phyllotaxis later, that we use the for loop is
think
because
you might
there
need
isn't
to-
a constant render like there's not a constant
Oh,
render.
this
like
is
in
not
P5.
like a.
It's not
Sorry,
like
I'm
Yeah.
of course. This is not a looping
It'll do it
function.
once.
I'm so
Yeah,
stuck in the
no.
way that I.
No,
Of
no.
course. So like this would be then.
Yeah.
Yes, that's better.
But this would only do it 100 times. It would be like. Oh, but we need to use this time variable as like. Oh,
But
I could
maybe
use
the
the
time
time
can be-
variable. Okay.
Yeah,
Okay.
I was gonna put it
I'm getting
outside.
ahead of myself here. I'm getting.
No,
I'll
but
let.
go, because
Yeah, no, do your thing.
time is better than it's
No.
outside.
Oh, wait. Okay. So I want to understand this then. Okay.
Yeah.
So if I were. Oh, the time should be outside.
Yeah, keep the time out.
Yeah.
Because it's kind of like a global
Oh,
variable.
would
Or
it
else
just be like a
it'll-
while true thing?
Mm,
Like to have it go forever?
I
Or
think
no,
that
that
might
can, like,
make it go forever.
Yeah.
Kill everything.
I've never used a while loop in a
Me
in a
neither, so
shader.
I'm not sure if it's gonna break our browser at the moment.
So this counter wouldn't need, because we don't need the counter because we have time, is what you're saying.
Yeah, exactly.
So if we did this,
Mhm.
just trying to get it to be back to what it was.
Perfect. And 100 is the most.
Wait, you want what to be back to what it was? Do you want there to be
Oh,
a
I
line?
was one the pink line, yeah. I don't know what
Oh,
I
you wanted more. That's what you were. I was like trying to see what you were trying to do.
Mm. You.
did. Oh, I know why.
Broken still.
This is outside here.
I think you need frag color to.
No, frag
Be
color needs
outside.
to be.
Yeah.
Oh,
Inside.
oh, interesting.
But wait.
And
I
this-
Oh,
still
right,
don't
obviously,
see-
because
And
of
then if I
yeah.
were to add time, like is time a count, a percentage of something, or like what's coming in?
So it's basically
It's a
time
floating
as soon
number.
as the program starts, because we're bringing it in from the 3JS scene, so it's continuous.
Right. But is it like 0, 1, 2, 3, 4, 5,
Yeah,
6, or is it like
it's a floating
it's-
number,
it's-
so it's probably milliseconds, like 0.1, blah blah blah.
Yeah.
so if you did this, it would do that very quickly.
Yeah.
I see.
And then,
And
but
then-
if you wanted to cycle back, you could use a sine or a cosine.
Oh, plus time. Oh, I see. Yeah.
Yeah.
I don't know what I'm doing here.
Maybe times. Yeah. Slow down
Sometimes
time,
sinus or cosines
And
help
then like
because then
that.
it goes back.
Yeah.
and it'll go back and forth. Yeah.
Yeah. Okay.
Yeah. So you can see
All
it
right, I'm
getting
getting the
pinker
idea.
and then getting
But it's going to stop after 100 times.
the for loop. Yeah, but
Yeah.
actually, if you want, I think you could also just take
Without
out
it.
the for loop, and it would still work.
Oh, because the time is variable. I got you.
Yeah.
I'd only need the for loop if I'm doing my own kind of counting
Yeah.
system.
So what we're gonna do when we create
Got it.
our dots for the
Okay.
for the
Got
pattern.
it. Okay. I'm understanding things better now.
But this is interesting to see the way that you like tackle that, because I wouldn't
Mm-hmm.
imagine to try that when I was starting, for example. So that's great to see how you were tackling that. Cool. So maybe now we can do a circle to show you how to do shapes and after
Awesome.
now
Yeah.
that you
Yeah.
can stop.
You do your circle. With I think you're gonna use distance. Yes.
Yeah, I love to
Yeah.
use
So there's like a few ways to get the position of the pixel in relation to the center.
Uh-huh.
There's like the distance function, which is Ilithya is going to use. Then there's also length, but I think that distance, when you read it, it just like reads more like you're reading a sentence. So you're checking where X and Y are in relation to the center point of the screen.
Which is 0, 0, not.
Yeah. Well, it depends on
resolution
how you
divided by-
set up the
yeah.
resolution, right?
Right.
But yeah. And then
No, actually, maybe.
I think you can just times it. Float. Yeah.
And
It's interesting.
Okay,
Yeah,
now
so
it's in
funny,
the
like,
corner, so we need to move it.
yeah.
So this is what we were saying.
Maybe
right?
that's good to as well to
Oh,
explain.
because you
to
didn't
that
do you
shaders-
didn't center it.
Exactly.
No,
And now I'm
exactly.
changing in the main function, I just put it in the center. I moved it back to that original
because
equation
it's
we had for
always
the
on the
UV.
lower left. I was gonna say that's why you start there.
And the so
Yeah,
it's so interesting. Like to me, like it's like oh, there we go.
Yeah.
Oh, I forgot the dot. I
You
always
forgot the dot.
Yeah.
So
And we can start the circle.
it's so
by the way.
is there a reason why you always start with like a 0 vector and then like add in something as opposed to just like oh, there you go. Oh, step.
I stepped it. That's why
See?
Eliza,
So
I wanted to show you step before. And maybe that's the best way as well to see it. I'm gonna go back a little bit so that it's more visible.
So we're not
Like with the
really
black circle.
creating. I mean, what is geometry in a computer graphics sense?
Yeah.
But we're not creating geometry through some type of, kind of like scalable vector graphics like sense.
No.
We're creating it by manipulating pixels in a very particular way.
And the space
And it's
that
like
you have.
And that's a normal thing to do?
Yeah.
Okay.
Because what's interesting is that once this is what we're doing today, like it's 2D, we're moving around pixels and we're tracing shapes that we recognize. But then one day in a future moment when you're like mega comfortable with this, then you can like create a camera in this space. And then you can add lighting and then you're creating, which you can all lay on top of a material. So you can have like a 3D sphere in a scene that has like a portal in it into a whole nother world where you've created a camera and like shaders are crazy.
Kind of what you can do with P5 and 3JS when you want to do 3D geometry, but P5 and 3JS already like did that work for you behind the scenes. So then we have like a very basic function when we want to create a sphere or like a cube in 3D WebGL. In here, you can learn the works of how to do it yourself
Shaping
by hand.
functions. And then you get into like, go ahead.
This would be a smaller circle. Yeah, got it.
Play with it. Yeah, so that you
and so it's all about like where is the pixel in space and like what color do you want to attribute it to, and the more that you're comfortable playing around with like bending space and time with math, basically, the more interesting shapes and things you can have.
And if I did, this is going to move it over a little bit.
Yes.
I think you're missing a dot.
Yeah.
Oh, no, you're not. Okay, yeah.
I guess for the 0, it was
For
fine
the 0, it's, more flexible.
Yeah.
So if you wanted to make more dots, that's where you would do a for loop and you'd be like manipulating these points. Got it. Okay.
Yay. Okay, so let's do that. Let's make some dots.
You can go ahead and try, Dan. So since you're like so fast, you can try, because that's how we got the Phyllotaxis that after watching your video when we were practicing.
Oh, I see.
Basically the same code that you're using.
So let's make like...
I was just, well, let's start with something very simple, which is just
let's make like 10 dots.
Yeah. Okay. So if I did I equals 0, I is less than 1, I plus equals some amount, and this probably has to have a dot. This has to have a dot.
Yeah,
I like dots.
Maybe
and then
we can make a count equal.
And this would all be, this also has to be,
I'm going to replace your just with the variable so that
Ilithya really likes it to have like code to be very simple to read, and she's very good about reminding me to.
What's driving me crazy is I'm like looking, what's the code pen like auto indent everything?
Oh yeah, I think at the top there's a little thing that says format.
Yeah.
There's like a little arrow that you can click on that says format HTML, if ever. I love both of you guys write such clean code. My code's so messy. I'm just gonna let you guys do the driving right now.
What did I? Oh.
Okay, so I think I'm just gonna vote that the GLFrag color needs to be outside the for loop.
Yeah. Hold on. Did you? Finish now?
Oh right. Oh, because we're setting them all at once. I see. Oh, I'm so confused.
No, you're on the right track. You got it.
But wait, but color then, color though has to be The color has to be outside.
Yeah, you don't need to.
But you would have
yeah.
to reset it each time? I'm confused now.
I'm letting you wonder for a bit.
Yeah. No, let's let him into it.
Okay, so if I'm starting at 0, I'm going. Oh, but I should be starting at like negative 0.5 and going all the way to 0.5, right? If I'm looking to like put the circles all the way from left to right.
Oh, yeah.
I think
that's one way to think about it.
Yeah, I didn't think about that, but you're already thinking.
Oh, but I could do it like this. But you would do it like this, typically like minus 0.5 or something.
Yeah, probably. I was gonna say that.
So, this just
maybe
has
you
to be
need
here.
Maybe this one needs to be a float.
You're gonna now you've.
I think.
Wait, so now you've defined. Yeah, let's get rid of that.
Oh no, I see. This has to be like this. But this seems wrong to me. Right? Oh, okay.
Wait, we have a dot.
Yeah, it's because I forgot when I created the variable for count, since that we actually have to define it as a constant, since it's gonna be inside the loop. So actually, I'm gonna just declare it in a different way.
Good call.
Because
why don't I do when I do this, color times equals 0 to reset it.
What did you? Maybe needs to be
what
a floating number, or what are you trying to reset?
What are you trying to reset?
Well, I can just keep color is a big
color is a vec3.
Yeah.
And
it's basically
so I'm thinking about this as a loop that's doing every single little circle.
All at once, yeah. Oh, yeah. But actually, it's a loop that is computing the color of every pixel based on the math that you're outlining inside of it.
Yeah. The distance between this different point and then so what am I missing here? I feel like now this is good. Yes? No?
Yeah, but I saw the circle and now I don't see it because we moved.
Yeah, it disappeared. It was there for a second.
Yeah. So
what did we change?
I wonder if
this is what I just took out, but
I don't think it was that.
Yeah, that shouldn't be there. I don't think.
Oh, I see. Can I give you a hint? And my mouse is here. Color is what type?
Oh, it's a vec3.
And circle is?
Oh, circle is a distance. So
the float.
Yeah.
Yeah. I think that should do something. No? No?
No, I don't think it was.
Oh, I was sure it was that. Wait, now I'm confused. Oh,
so
okay.
Everything is one step. I was just trying to make them smaller.
Maybe it was huge. Maybe it was
Wait, we had the dot before. Was it so big?
Oh, there is.
We have a little tiny sliver.
But wait, what did you move?
Okay, wait. If I get rid of the 0, 0 now, then we get a red sliver? Oh, white. Okay, okay.
Right. Well,
okay, so then I think here, we need the -5? I think we need a dot next to your 1.
Oh, I'm obsessed with it being the other way. I don't know why. It makes no sense.
Okay, now we've got some circles. So I took away they're a little bit compact, but they're there. I took the -0.5 away. I don't know if that does anything.
It was just making it like.
Oh yeah, so you've got it centered. You were correct, Dan.
This would make them. There we go.
Yeah, there we go.
That's what I was trying to do.
Little dots. Okay, cool.
So wait, I'm trying to the thing that's confusing me is that I'm still stuck as to why we're adding onto the color and getting multiple. there's like something in my
Oh,
brain.
okay. So color plus equals and color is like, well, I don't know. Alethea, were you going to say something?
I was going to
'Cause
say that because remember that we have to render whatever we're going to render has to be like kind of outputted via GLFrag color.
Right.
And what do we have in GLFrag color right now? We have color, right? So we need in these three vectors, whatever we're doing, like the circle, the square, whatever we're manipulating, either if it's like still a shape through the pixels of the color, needs to be here. I mean, the variable could have been named something else, but as long as it's a vector tree and that you're pushing whatever you're doing there, that's why you have to push it to that. We just call it color, but we could have call it something else as well.
Yes, yes.
But like the baseline being like you put in a pixel position and you get back a pixel color. So we start with UVs and we end with color. And then everything in between happens.
So this is the code for one particular UV.
No, it's for all the UVs.
For all the UVs.
Every single pixel has U and V, and this calculation.
But this code is applied once in parallel once for every UV.
Mm-hmm.
But then this loop here gets a given UV
for every UV. For every pixel position, what side of this is it on?
Yeah,
And then
you could also use length. Maybe
you do that calculation.
Do you know like to make a circle with length? Because that's the other way would have gone. That you use length and you put the UV there.
No, I understand the concept. I'm just trying to understand the parallelism here, because to me this loop is adding to this one color vector multiple times.
You mean the plus equals part at the bottom?
Yeah.
Yeah. Think of it like Photoshop. You know how in Photoshop, if you have layers, and the way the colors mix is a bit different. There's like additive, there's multiply. This is like additive. So it's making white and it's making bright versus everything around it is black. I don't know if that's helpful.
No, I guess so. This is what I mean. Like if I comment out the loop and just put in the number like 0.5 here, like I'm doing it for the middle one, then I'm gonna get the circle in the center.
Yeah.
So to me, that's why I keep wanting to put this reset in, because as we're looping through to do each one of the circles, it feels like we're adding on top of the previous circle, which could be like a problem. It doesn't matter here because they're all just white.
Yeah.
But does it work if I put? I think I'm going to understand.
I think you need to reset it.
Me neither.
Does it do anything if you reset it? Does it get rid of it? Yeah. Then you only get one. Yeah.
Only get one. Yeah.
So then you're wiping it clean and you're only getting the last one of the 10.
Yeah.
The last one, which we don't see.
And we want all of them.
Okay.
Yeah.
But I think also you're thinking maybe about it within the context of like the draw lid.
Yeah, exactly. That's right. I'm having trouble getting my brain out of that.
Yeah. So now we have 10, right?
Because now when I think about it, about your question, then is that when,
Nicole in the chat is saying each loop in the for loop is like a sheet of transparency paper.
That's the Photoshop layer.
So there's actually this color vector is like, I get it.
That's why we like to think of Photoshop. Like
black and white, it's like a harder analogy to picture, but if we had like multiple colors and you were adding them, like it would get so bright, but if you multiply, then it's like more burned image or colors.
I got it.
Sorry, Alethea, I interrupted you.
No, I just wanted to say that in the end, whatever you're going to draw, you have to kind of overlap it together all the time. Like that's why we like this Photoshop or Illustrator kind of like analogy that you always have to create like a new layer, right? Like if you do one geometry, just as well, so that if you want to edit something, you can go ahead without messing the whole thing up for example, we could have started by greeting all of this inside color, but then it's more complicated, right? So
Yeah.
it's better to kind of split
Yes.
it. And then every time you want
Yes.
to add the layer, you said that. Now we can also use mix, which is a
Ooh,
wonderful
yeah.
function.
It's Alicia's favorite
And then
function.
you wouldn't need to kind of like add it. So
Right. Right.
maybe we can try that too if you want to
Yeah,
learn
we can do that.
too.
Mix is great.
I want to share the.
But the adding thing also threw me a lot when I first started coding
Yeah.
shaders because I had done a lot of web development too, and I was like, but wait, so how do you make more of the same thing? And like, how do
Yeah,
I
so
do that? And then I thought it was so
I'm gonna
complicated,
comment
and
this.
really,
then you would
that's why I
say
was like, oh, math
color.
is so cool. I can just like put everything in a bowl together, and it does the thing.
And then you start by color, circle color, and then
That's almost like
in here
Like an
it's gonna need to
interpolation.
be.
Mix is like is a lerp,
Yes.
yeah.
I'm gonna do that because I cannot see. So in here we definitely need the vector tree because color is a vector tree. So all of them need
Yeah.
to be a vector tree inside. And now we should be able to see the color. Hold on.
Wait,
I
you're
can see.
mixing color with the circle.
Maybe I have to move. Sometimes
Yeah.
I forget about the position of it.
The order of the.
why is color in there twice?
I was gonna
Because
ask
I
the same
want to add
question.
it because I want to add it together. So, but wait a second. Why is it not? The interpolation is the color and.
I think you need a mix.
Like, wouldn't it be like, to me, it would be something like this, like half of one.
Oh,
Whoops.
sorry.
Oh, ah,
Too many drivers.
I'm sorry.
No,
I was
I'm
saying, like,
taking my hands off the
There you
keyboard.
go.
It's all good.
to me, it would be like this.
1.0. Yeah.
Mm.
Yeah.
Yeah.
Oh yeah.
Then
yeah,
then we
okay.
get a little gradient. We get white, gray,
Right.
to black. Yeah.
So then actually it's 1.0 if you want them fully black, I imagine. So
Interesting.
Yeah.
or maybe by changing, hold on, because that's when what I think about mix two is interesting, that if we change the position of them, it's gonna back to
Well, then it would be,
Yeah.
this would be the
Yeah.
equivalent
Then
to what
that
we
would
just
be
did.
at one
yeah
point.
what
Yeah.
we had
Point one.
kind
Yeah.
of.
That's basically, mix is basically the equivalent of lerp.
Yes,
The lerp
yes, because
function
you have the
in P5.
interpolation
Yeah.
at the end and the weight
Yeah.
of the two values.
And you can use it with all kinds of stuff. Like I
And
use
you
it with
can still-
position a lot instead of.
Yeah.
Do 1.0 as you had it, so if you wanted,
Yeah.
Ooh.
Ooh, that one's fun. There's an optical illusion there.
yeah,
Dark.
which
White,
I
dark,
didn't
white,
expect.
dark.
I just
No,
wanted
me
to,
neither.
to do the 1.0.
Yeah, I'm like trying to look really close at the screen to understand what's going on.
That's fun.
So we started by just using this very simple distance to just do left to right. But the Phyllotaxis pattern, we could just calculate the relative positions of each like spot in that pattern here.
Yeah. So
Yeah, at the angle.
I'm gonna replace this vec2 calculation that you have here with, where are you right now? I'm gonna plug in this guy, center chords, and I'm gonna say center chords because now
I
you're
make the
checking
count?
the distance based on the
Yeah.
center.
Like I
Does
could
that
make the
still
count
work?
100
Yeah.
and then get
But
basically.
still needs to be a
and-
float number, so I'm gonna add the 0.0.
You always need the
What?
dot.
Just because it was a float, otherwise it's going to break.
Yeah. Oh, what is the angle? The special
137.
7.5.
0.5.
Yeah.
Yeah, I memorized it from
then-
your video.
I'm actually looking at the code here. I just pulled it up.
Yeah,
So
yeah,
it would be
yeah.
the square
It's pretty
root
much the same.
of
I,
I.
yeah.
And C. What is C? I have that in my code. That's the. That's just like a.
Is the scale of the pattern, like the spacing
scale, yeah.
between the dots that
Yeah.
you want to.
So that wouldn't be 3. It would be something much smaller. Like I was
Yes,
using something
exactly.
like that. 'Cause
Yeah,
we're-
you got it. Well,
we're-
I told you he was.
And now he's flying.
quickly.
Now
Yeah,
he's flying.
exactly.
Yeah.
Center
keep it up.
coordinates would be. Oh, I see. So then I could just.
You can
So
do
it's not
float
really center.
X.
This is the set. It's not the center coordinate of the space. It's the given circle. Like this is really like circle coordinate.
Yeah.
Yeah. Yeah.
Or
And
like
you
we
can
could call it
define now the
and
X.
then X would be
Exactly.
R, and so
Yes.
we need an R, which would be something like 0.5. Oops.
Well,
And
you already
then
had
X.
the R. Oh, okay.
I did?
Yeah.
Yeah.
I mean, you already had
Oh,
it
right.
in here.
You
No,
already
of course.
defined it,
R
so
is part of it. R is the distance out from the center.
Exactly. You
which
don't
is
need to.
the pattern. Yeah. I was starting with something I was doing two things in my head. I was like, the next step before Phyllotaxis was just put all the dots in a circle. But
Okay.
we could jump from one to the other. And what does this give us? Oh,
It's coming.
So this needs to be radians. 137.5.
Yeah.
So 137.5 divided by 360.
Well, I would say
I think
I'm gonna add our pi in here so that we can play with that. I'm just gonna put it at the top.
Oh, right. Okay.
We've got pi and pi2 now, in case that's helpful.
You put those on just as constants at the top. Oh, okay.
Yeah.
And I was gonna say there's a GLSL variable for either radians or degrees.
But I think if you like multiply,
if you want to like define
it. Converting it.
So
okay.
So what did I miss here?
I think.
Oh, A. This is the angle, not R.
What do you mean?
A.
Ah, yeah, true.
Okay.
Okay.
So
maybe the space we can increase the space
in
between the dots.
Yes, C needs to be much more higher.
Yay!
Yay!
We got it.
Hey. Oh, we don't have the little whistle. We can't toot today, but we got it.
No.
Yay!
Yeah, you see, and it's like.
I don't know why my computer just decided to like.
Hey.
My computer decided to go really, really slow. Are you kidding me? Okay.
Yeah,
we're still getting you.
Let's put less dots because we realized about that when we were practicing on CodePen. Put 50 instead of like 100 because it's the count. It seems that it's too much.
Depends on your computer and your graphics card and stuff. That might be better for you.
Just by lowering the amount.
But also, like Philippine is saying in the chat, it's very inefficient what we're doing. It's fine. She's like, it's so rare to see this kind of code in there, but I love it.
Yeah.
I'm pulling up the chat.
Yeah, I totally missed the chat. I have
executed for each pixel. Yeah, true. Well, so we've often talked about this on the stream, like how efficient or / inefficient is a for loop. So it's already a nested loop. Wait, so can we do this without a for loop, Philippine?
Right, that's what I was trying.
Tell us.
In my head, that's what I was trying to figure out because we just.
Oh, Philippine, give us a hint.
Yeah, we can figure.
How do we do this without a for loop? Because like in the
same. Because it's executed for each pixel. That's why the add was confusing me because if we're doing this for every pixel, we just need to check if this given pixel is one of the Phyllotaxis spots, right?
Oh, okay. Yes. You can convert to polar coordinates. Oh, right. We didn't do that. That is something that you do in your video too, Dan, where you do the bridge.
Oh, you mean convert the UV?
What do you mean?
Which is Cartesian, right?
Yeah.
I think. Yeah.
And
coordinates.
Modulus
too. It's true. The way that I calculated the angle and when I played around with this code,
I wanted to try something.
I'm going to put it as a comment so you can see, but this is the way that I did it. This is my way. Well, my way. It's the way that I found looking around on the internet. But I use modulo.
I just use the number without converting anything. So just 137.5. It's actually like and makes the actual shape. So you don't need to convert it. Do you see that I tweaked that?
Yeah.
So
Why?
if you use the 137.5, you actually get the picture of the.
Why?
You show this PDF with the degrees, right?
Yeah.
So do you have it there? So if you
Is the
use it,
shader working in degrees automatically, not radians?
I thought that, but when I was tweaking it, because I thought, oh, maybe I need to use like degrees, the function that I told you that shaders has,
Yeah.
but actually you don't, because it seems
You
that
don't
it's.
need to.
Can somebody in the chat tell us that? Because I'm gonna pull the PDF. Hold on a second, so that we see that we actually get the shape without. What was the name of the PDF? Do you remember, Dan? That you point
I have
in
a
your
link to it. It is.
work. If you
It's
can
from
share with us
like
in the.
algorithmic botany, maybe.
Yes,
Yeah,
that
here
one.
it is.
Oh yeah, botany. Yeah.
Yeah, I can
I
put
got
it in our like chat here.
Yes, exactly. Put it in the
This
chat,
one.
so and then we can compare. And I'm
I
gonna
can put it in the.
let's make the dots maybe a little bit smaller so that we can.
I put it in the Twitch chat as well.
Yeah.
Thank
Great.
you.
And now
Yeah,
I'm gonna
why?
put it on Twitch
Okay, wait.
for everybody to
So
watch. So you see the patterns on the PDF. I put it for everybody on Twitch to see. So we're aiming
but
for the 137.5, which is letter B. This one in the middle, right?
yeah.
Yes.
And I believe it's that one, isn't it?
All right, hold on. Let me just. It really should be this. What did I do wrong? Oh, dot. I can't remember the dot. Yeah.
I forgot to.
Okay.
So,
But that totally changes the pattern. It's not really
I
fun.
know.
Like the. I try that as well. So can somebody in the chat respond? Why is it really like coming in degrees in shaders? Because that was my understanding, that then maybe it's not radians.
Yeah.
But somebody is quiet. People is quiet in the chat.
I'm not sure I'm following you guys now.
The
I think that we
input
have
to the
do.
trig functions are in radians, says J2RGB.
Yeah.
And why does it look more correct
Exactly.
when
That's.
we're calculating the angle without converting it to radians?
Mhm.
I mean, the thing is, like, it's just a pattern, right? So we could put any number in there. So we're to get. Oh, I cannot for the life of me put a dot.
And then we're gonna get a pattern.
You know, we'll get something, but it should be.
Basically, just to because I think
Maybe
Eliza
the
got lost.
spacing.
I thought we were trying to figure out how to do it without a for loop, but now we're.
We were. We got
I was like, wait,
distracted.
where are we?
We got
just got
distracted
stuck
by
by the fact that
The pattern.
remember like the pattern in this PDF.
Yeah.
Like if we put 137.5 without pi, without anything, just by itself, it really resembles the image. But if Dan transformed now the degrees as he's doing, we see this like ellipses, which is not close to what we see in the book. If you look at the letter B, right? Because in the book it says that 137.5 degrees should look like this pattern. This is what we were
okay, so
like, discussing.
I will say that the one difference in your code and mine is that the radius that you're calculating, I calculated based on the I divided by the number of dots.
Ah.
Yeah. Now it's smaller, but maybe I don't know if that's helpful.
Put it back.
They're so small.
Oh, it's too small. Yeah,
It's
still a spiral. It's still a spiral, you know. So I could see it there.
Why are we dividing it by 180?
Convert
because
to degrees.
this is to convert to radians.
To convert to radians, I thought you were like.
So if the angle is 137.5 in degrees, 180 is the number of degrees in is pi in degrees. So pi times 137 0.5 divided by 180 would be the angle in radians.
I thought pi was a radian. Like, isn't 2 pi 360
Yes, yes. So, but 137.5 is not in.
Oh, right. But then, okay. Then in my brain, I've always misunderstood this. But I thought if I multiplied something by pi, then somehow in the mix, it was like spanning both universes, because we were talking about.
So that's, yes, we need to multiply it by pi, but we want to take that angle and divide. I mean, I could be wrong here, but we want to divide it by 180, because basically we're trying to, like, if this is from 0 all the way to pi, this is 0 all the way to 180.
Okay.
So like 90 would be 0.5 of pi.
What
so
if
90
you
divided?
So I also did this. Well, did we keep my code up here? Yeah, see, so like up here, I did like where you have your R, I did like, I used modulo between wait, where did I put, well, because I used different variable letters, so now I'm confused. But I did use this originally in my code was a B. But I did modulo.
Still a spiral.
Strange. It makes sense. And then
needs to be a floating number.
Oh yeah.
Yeah, just to remind you, whatever you might change.
I don't. It's so strange. Yeah, I just was like doing it the same way.
Yeah.
What about changing count to 2 pi? Yeah. That's kind of an interesting idea. Pi 2. And that's not really, that's just doing less of them, but
yeah, it's still a spiral.
Well, you know, maybe we shouldn't question it too much, and we should just like enjoy the fact that this will come back to it.
For me, it seems simple, and I'm gonna go back to the simple one, Eliza. I'm just gonna, because we don't need to divide or anything. We can just take the code from like the original, just the squared form. And,
oh, whoops, hold on, let me.
I think it's what's 0 point. Yeah. And yeah.
All right, let's. I think the more interesting question here is how to do this without a for loop.
Yeah, exactly. So if somebody knows about this, just put it in the chat. What we were trying to decipher. What's this word?
Decipher.
What we were trying to decipher why the degrees kind of translate to radians. That was what's happening right now magically, right, Dan? That the degrees are magically transformed.
Yeah, I mean, if we
without being transformed.
Just like if I did a pi divided by 2, we should be getting sorry, your name is in front of the thing that I'm typing, so I can't see it. There you go. Okay, 0.0. Like this everything should be at a 90-degree angle. Yes. Okay.
Yeah.
But wait a second here. I think we're off by some kind of scale because, oh no, or I'm not thinking about this right. I think we might be having an issue based on the way we're doing this for loop. Like, why are we not seeing anything? Why are we seeing everything perfectly vertical at night? Like, I would think these. Should it be additive? Like, does A start at 0 and then it's like?
Ah, okay. Nothing happens. Hold on. Oh, it has.
You need a dot.
Hold on a second.
That's how we learn. I joke on my channel, like, yes, okay.
Oh, cool.
I was expecting to see that.
Okay.
So with 90 degrees, so is that the issue?
Then you can take back. Okay.
That we're adding. Yes, there we go.
Okay.
I think maybe I forgot to or did I have it multiplying by I in my code?
Yeah,
also?
it was multiplied by.
Oh, there it
was
is.
multiplied
Yeah.
by I. It was I.
Yes. So actually, we don't
I,
need to add it. We just.
But we don't need to add I in this way. Yeah.
Okay, hold on. That's
because-
fine. Oh, but I is not a counter going up by 1.
You know what? Thank you, because I
There we
was
go.
wondering about this. So
There we go. That was the issue. And it needs a dot. It needs a dot, I guess. It's only going to be 10 circles now, which is fine. There we go.
Yeah.
So let's make this 100. And then spaced closer.
Yeah.
Yeah.
Too close.
Very close.
And they could be smaller. They could be spaced further. That's so adding it. Okay, there we go.
Wait
There
a
we
second. I'm trying to digest what you did, because when I was practicing on Eliza 2, we couldn't figure out why the pattern of like this degrees / radians converting it was working, and now it is because. Okay.
I've always
we
just
had
thought it was 2 ways of saying the same thing. I never really
We,
thought of
we
it.
had forgotten to.
You have a dog?
No.
I didn't know 𝗬𝗲𝘀𝗀𝗀 had a dog.
Oh, because we went. No, the main issue with this, we were putting in so many extra circles, all like really close to each other, that the point of this counter, at least and I already now have like made my machine die. Yeah, it's kind of crazy that I did this in a way that, okay, hold on, wait, what? A dot, this dot.
Exactly. Yeah. I was just thinking of that, and I was like, is it this dot, or was it a console dot? No, it was this dot. Yeah.
Okay. All
I'm
right.
back.
So wait, now I want to go back to the no for loop question.
Yeah. So. Oh, Shar!
Yeah.
Hi, Shar! Yay! Oh, and Rob is here. Hi.
What did I miss, by the way?
Nothing.
Did
You
explain
missed
how-
us forgetting to put a dot. Hi,
okay,
everybody.
Always with shaders, it's the dot.
Yeah.
I don't have a dog.
It's either the
everybody.
dot or the
It's not-
semicolon.
It's not my dog. I was
I do have a dog,
sitting.
but
I was dog sitting,
I
and my
let
neighbor
her-
came to fetch.
I usually have my dog with me, but I
Oh.
decided not to. I don't know. She's somewhere else right now. She's in the house.
I have a dog. I used to have a dog, but they live in Montreal now. So far away.
I just dog sit sometimes.
So Flippin was saying we need to do the conversion to get out of the for loop.
Right.
does that
The
mean?
conversion to
Conversion?
polar coordinates of UV.
Ah, okay.
Yeah.
Yeah, so that's easy in the
Ah,
sense.
Interesting.
Is your
That
dog's
it
name
is.
Gloria?
Yes.
Okay. People are saying, how's Gloria, and
How's
when are you
Gloria?
coming to Paris? Dan was in Paris a few
Ah,
years ago.
okay.
I know. Well, when can I mean, I guess I can. Yeah, I don't know when I'm going to be. Soon, I would love to come.
Wait,
to Paris.
you can come to Paris during your year off
Yeah. Yes.
that you're about to take, which is exciting.
I'll be back as well.
Yeah.
Again, I mean.
Really?
I'm gonna
coming
fetch
back to
some
Paris?
water. No.
Okay,
I
sorry.
mean right now.
What? Okay, cool. Sorry.
So,
A10, Shar says.
right. Yes. So you would do the angle would be A10. I mean, the way that I usually do this is with. How do I get the individual x and y's? Oh, they're just in x and y.
Yeah.
No.
uv.x, uv.y.
uv.x. Yeah.
And I think you need
but-
it needs to be just A10, not number 2.
Not A10 too. Yeah, no A10 too. Yeah.
But so usually the reason why I use ATAN2 is to get the angle, like if you basically, I guess maybe the ATAN function in shaders knows how to do this.
A10
because usually
2 for x and length for y.
Just
They're
explain what
saying
you
in the
were.
chat.
Let Dan. What were you saying? Because maybe.
So
we can do it
normally
another
you
way.
would, so I like basically like tangent of an angle equals the y over the x. Like I'm not writing code now. I'm just writing an explanation.
Yeah.
So ATAN, if you want to solve for the angle, you would do ATAN of so this is uv dot y divided by uv dot x. The problem with this is this could be negative, or this could be negative. This could be negative and this could be positive, or this could be positive and this could be negative, and you get the same angle out.
Got
and
it.
atan2.
But there is no atan2 in GLSL.
But there is no
I think.
atan2. You just, if you don't give it a single number, you give it the two values, it gives you the angle. Is what we're learning. What I'm learning.
Yeah.
And
but
does
what I
x
was
go
gonna
first
say
or
is
y?
we could use tau to normalize it. I'm gonna define
Oh,
tau at the top. Well, actually, it's pi2 tau, isn't it? So
I think.
Yeah.
yeah, so
Yeah.
you
And
can use
then
pi2.
R would be the square root of uv.x plus uv.y times uv.y.
Okay,
This would be
now
the conversion.
I'm lost in the math. I'm not great at angle stuff.
So the math is, it's funny, like I'm so used to having like a whiteboard or something to draw on, but like I just use my fingers.
I know that 2 pi is a full circle, and I know that
Yes.
tan jumps off the page and goes into infinity.
Hold on, I think I have, let me give you a diagram you can pull up in the chat.
Okay.
Because
Yeah.
polar coordinates, let me find
And by the way, what you
diagram.
were trying to normalize, Dan, I believe the way
Yeah.
to do it in shaders, because there's no atan2, is then you divide it by tau, by the full circle, like pi2. This is why I added in here. So then we can normalize, like you were
But
saying.
I want the angle between 0 and 2 pi. I don't need the angle to be between 0 and 1.
Oh.
Between 0 and 1, you
I
said?
think.
So then we could use apps.
No, this atan2 should give me an angle between 0 and 2 pi, which is what we want.
Yeah.
I mean, you're right. If we wanted to normalize the range of an angle between 0 and 1 to like
Yeah.
map it to a color or something,
so-
we would
yeah.
do that.
Oh,
Hold
okay.
on, I'm looking for.
Now I'm
this-
remembering Shar using atan something something to get an angle in another thing at some
I'm
point.
looking for my.
It's funny that she's the one that suggested it.
So here, oh wait, okay, hold on. Copy image address. This is like a little diagram that you could look at. Let me put it in the chat.
Yeah, then I can pull it up here on the screen too.
I mean, I have like a whole video on this topic.
Got
but,
it. Okay.
So in other words, if you're looking at this diagram, what we're looking to do is calculate the R. And if you remember the Pythagorean theorem, this diagram is about doing the opposite. Right.
Yeah.
But the Pythagorean theorem is a squared plus b squared equals c squared, which in this context would be x squared plus y squared equals r squared. So r is the square root of x squared plus y squared.
Yes. Yes. Okay. And this is just atan.
To get the polar coordinate, we need both the angle, that theta, and
the
we need
length.
r.
Okay.
So the angle, this is theta. So theta,
circle
it's not
with
in the
the-
diagram because I didn't put tangent in this diagram.
Okay.
So theta is solved. It's like I'm using my mouse to like gesture on this diagram, which nobody else is seeing.
No, but I can
It's all
just
good.
for
Like,
you.
No, I'm
I should put
following.
it behind
I'm
me.
following.
I could actually
Yeah,
get this. Hold on. This is going to be very exciting.
Oh, it's true because you have a green screen.
Yeah.
Yeah, that's true.
Except Google Meet is actually not. Hold on, let me do.
Shar with her pi emoji. I love it.
Hold on. I'm going to
atan
save
limits
this
are
image.
minus 2 pi and 2 pi. Flopin says that atan limits are minus
Okay.
2 pi.
So it goes.
Negative
That's
pi
fine. It
plus
goes.
2 pi. Yeah.
It goes around
Full
backwards
circle
too.
and-
So hold on. Where do I go to visual effects? Is that where? Yeah, backgrounds. Hold on. This is going to be very exciting. I'm going to get this.
So
stacked.
hold on. So maybe we have what you wanted done, as I understood from Flopin, actually. So, but you go ahead and put so that you explain.
Well,
Well, I was just trying to explain.
Yeah, do it. If you can put your background.
Why?
We'll wait.
Hold on. Let's see. Hold on.
And- Let's see.
Hold on.
2 pi makes the limit between negative. Yeah, 2 pi normalizes it. Atan limits are 2, and then divided by 2 pi makes the
I
limit.
didn't know that it was minus 2 pi and 2 pi. I just knew that you needed to normalize. I love it that so many.
There we
shader
go.
pros
Now
are
we've got the
chat.
graph.
Is it backwards or it's just backwards
No,
for
that's
me?
how I saw it. No, it's great.
Okay, so
I love this so much. Okay.
so this
Amazing.
this here. Oh no, my God! I'm mirrored, which is like very confusing.
You see it the other way.
Oh yeah, if I go this way. Okay. There we go. I can't do it. It's like I can't get my body to like. Anyway, I don't know how helpful this is. X squared plus y. We want to find. We know the xy of this point,
Mm-hmm.
and we want to find the r theta. So theta is solving for this angle is done with atan.
Got it.
So, but that doesn't tell us how. That just tells us the angle. It doesn't tell us how far away from the center this point is. To find r, we do that with x and y.
Okay.
So x squared plus y squared equals r squared is the
Got it.
Pythagorean theorem. So to solve for r is the square root
The root
of x squared plus y squared.
Yes. Okay.
Which is what we had.
So I don't know how we make this not do anything related to the for loop, but now we have, instead of, basically we have our own, like, polar coordinate is r comma theta.
I think I do see now a little bit.
So now we have a polar coordinate. I just don't know what we do now down here to, like.
I can comment. Hold on. Let's make a copy of this for loop. And I'm gonna put this here above. Because the idea was that we needed to get rid of the for loop, right? And use that instead.
Oh,
so
we
can start by commenting the loop.
So we would look at distance of each pixel to the points in the Phyllotaxis pattern, but no, we'd still need the loop for that. You need to manipulate the UV into a spiral. You could visualize the polar coordinates by using theta as x and r as y. Oh, I'm so confused.
Wait,
Theta
I think
x and in the circle coordinates.
Oh, length v returns. So this we can just use. Shar is saying, I lost this chat message, that this is just length UV.
Yeah.
Is the equivalent of that.
Oh, okay.
Basically, you need to figure out if that specific px is inside the circle. Okay.
But I'm still lost and curious on how to do what we had without the for loop. Now that, for example, I commented out the for loop, and how can we have the dots without that?
GLFrag coordinate RG equals polar. What does that even mean? Use smooth.
No, we're not going to use smooth step. Let's stick to regular step. But I understand. I think I'm remembering, like, a workshop I did with Shar where she drew a spiral of colors using atan and.
Well, that I would understand how to do as mapping,
but not the dots.
Mapping the. Okay, so hold on. Like, we could just start with something simpler just for a second.
So make
which
the
is basically saying color, like, okay.
I'm gonna comment that out so that we can.
Yeah. Okay, hold on.
Color here.
So, like, if we just for a second say color plus
Right.
Go ahead.
Color, just right here we say color plus equal theta.
Yeah. Go ahead.
We're gonna get and now we would want to normalize this to pi 2.
Yeah. And then it's gonna be a little bit.
And
now exactly. Yeah.
But I guess it goes. But there's something about it going between -2 pi and pi. So, like, is that really true? And then we would do this. Pi. Basically, we want pi 4.
I think it has to be like
a dot.
Oh yeah. I wondered. Two dots.
Okay. Yes. So this is the color going. I mean, it's not all the way around from black to white in a. It's very, very. Do I have? Is that the full range from black to white there? I can't like visually really see.
I don't think so. I don't think.
For me,
it looks like it's starting from.
It's gray. It's
like. You sure we're using atan 2 correctly? Usually atan.
I think that you can also just do it like that, divided by.
But that's the issue. Like, that's when we're not going to have the different the quadrants.
Yeah, I think it's better with the like in a 2-vector
Okay.
way. Yeah, if you move the coordinates, it's just gonna move the origin of it, kind of.
So you just
It
someone's
goes
saying
from negative pi to pi.
we just need
Okay,
to add
great.
pi.
Got
Yeah.
it. Okay, good. We're good. There we go.
Okay.
That's the full range. Okay.
Yeah. Yeah.
So
okay.
now I understand so basically that's doing a spiral, and we could also then use R. So for example, if this were I can add a vec2, right? Or vec3 if I were to use theta for like the red value and like R for the blue value.
Maybe that, yeah.
You would see
Ooh,
this.
so pretty. Yeah.
Because it's the gradient. Now, it would be more interesting to make this match at the end, but that's a different math problem that we're not necessarily needing to do. So now how do we make this related to Phyllotaxis?
Hold on, Flopin did something really quick. Yeah. I'm gonna check what she did.
Yeah, let's peek.
I'm gonna put it in the screen so that we can all pick. Thank you so much, Flopin.
Thank you, Flopin.
So
A10 center. Okay. So she divides 2 times pi.
Whoa,
radius.
Look at that. That's cool.
Yeah. Oh, and then she uses Euler coordinates.
Okay.
Cool. Centered out x.
That's converting it back. Yeah. Angle is a tan 2, center x, center. What's center?
Center is floor of UV plus 0.5. So that's like, she commented that it's domain repetition. She's creating the cells, I guess.
Oh, that's making it a grid. That's making it like a grid, which we don't necessarily need to do here because, so this is interesting. So,
go to our code.
Oh, I got to understand this. Boy, this is, I'm trying to think here. Get back to that thing where we're adding for, I keep wanting to put a for loop in. I'm like, my brain just immediately goes to, okay, so now we add the for loop to, but like, so just to understand this, if we did, how does step work again? Like if we wanted to only do like half of this, like if the angle is less than something.
Yeah, so you set your break point and you say like what side of my break point does the pixel fall on?
Oh, got it. Yeah. Yeah. So that would be like, just to remind myself that would be like color equals step, the angle, pi.
Wait,
like if
you only have 2 values in step.
Oh. Because it gives me a 0 or 1. It gives me a 0 or 1 whether theta is greater than or greater than or less than.
Yeah, exactly.
So this should be, this has to be plus equals. So this is doing our like what we did at the beginning, but with the angle. Yeah, got it. Okay. So
now it's flattened, so we don't see the
so
gradient.
then we could also do R. Oh no, okay, we could do color plus equal step R 0.5. This would be doing our circle again. I'm just, Got it. Back to the circle.
No, back to where we started.
You're constructing a grid with them, then moving the circles within their individual cells. Yeah. You can't, right. Yeah, the Phyllotaxis is not the same as it's a similar, there's like some thread there. So what I don't understand is, I think what I would do is like color each pixel according to its location in the spiral. So like, for example.
So then the spiral becomes the break point.
Yeah, but smooth, you would, this is where it would make sense to use like smooth step.
Okay.
I forget how that works.
That's exactly it. And then the first number is the amount of smoothness you want. So like
the interpolation.
the place where you're breaking the hard edge.
So like what a lower number would then be?
A harder line, I think, or a softer line.
Look at that.
It's like the interpolation between the two values.
That's interesting.
Yeah, because the other thing that I was thinking is when I've done like a grid of dots, I use frac too. But
we did talk about this the other day, but then
but to get this pattern of the Phyllotaxis, which has this kind of spiral, is where I was like, okay, maybe I can use frac, but then because frac is another GLSL function
that divides the space.
That divides the space. For example, we could.
But I don't think that you can, like, if you're gonna do fract, then you might as well do because like how do you move the boxes around once you fract them?
Exactly, that's the problem.
Then you need a matrix, and then that gets very complex.
Yes.
I mean, we can do that if you guys want.
Oh.
I don't know if you want. I'm not going to push matrix math on anyone.
No, I was just kind of enjoying like the arbitrariness of suddenly having polar coordinates.
Yes.
Well, that's it, right? Because if we have them, I feel like we can't be far from it, because if we can do a circular pattern with the colors, we must be able to make dots.
Yeah.
And then
so the issue is we would need to use the time. We could use the time counter, right? So like basically, what if time is u time?
Time is already here. Yeah.
And what if we used the relationship between R and where it what was C again? C is the spacing.
Yeah.
That's an arbitrary number. Like, in other words, like, I think there's something interesting to be done with,
hold on a second. Yeah, because now
putting time here.
Wait, let him finish his thought.
Oh yeah, sorry.
I just don't have a sense of what the because if we did. I lost.
Oh wait, it's because I think, is time called time? No, it's you. Oh yeah, no, you're right. Time is time.
It's just I redefine time. I mean u time as time, so that we don't have to type u time every time. So.
What did I just do? Oh, I already have C in there.
It's fine.
Yeah. Okay.
So if we did, just for a second, like if we did, where was that step with R? Here, like. Just do
something is broken, I feel.
Wait, yes, no, I want to just get back to step regular. What's regular step again?
Step is like breakpoint and position. Yeah.
Okay. Oh no, so breakpoint is first?
I think so.
Oh, what did I do?
But wait, something before that stopped working already.
Yeah, I removed the cones because you didn't need the cones at the moment on that end.
The what?
There was a cons here.
Okay, you can't. I can't take the square root of
time
for some reason. Doesn't make sense. Oh, because no, I have R twice. So let's call this Phyllotaxis R.
Okay.
Yeah. Okay. Great. So what I was gonna say was. Phyllotaxis R. There we go. Okay, so this is growing now, but now if we also do this with, so let's make this only the like red value.
Got it.
To paint it, you mean? So okay.
Oh,
I think you need a dot.
You need the dots on the. I love it because I think we used to make this mistake so often.
Do you have all your brackets?
Oh no, Vec 2.
Vec 3.
Vec 3. Okay. Yeah. Okay. Okay. And then if we also did the same thing but with the angle, Hold on.
With
Let me
T.
just put something in here.
Oh.
So the angle with Phyllotaxis is based on this.
Oh, the one that you had pi.
And this is time. We're animating it, which is not the solution, but it's like going to hopefully do something interesting. And then if we look at our current pixel theta, wait, is it the break point for? Yeah, theta. Oh no, we want a theta. I mean, step is going to be weird here. There we go. Okay.
Cool. Okay.
So we have the angle, the angle going. So now we should be able to do something with smooth step. In theory, that would like.
Yeah, it's blowing my
repeat
mind.
the...
Which one?
That was kind of fun.
Yeah, yeah.
I wish I could get it to start
it.
over. I like.
Then you need a sign here. I think.
So that
Yeah, but that's what.
Here I'm back.
Oh yeah.
Yeah, but what I yeah. So that's what I'm trying to do.
You wanted a continuous.
And let's not let me not use step for a second. So like for example, if we just add oops.
I'm gonna remove the
oh no, but I want time here. So this now is just, and this would be, the color is theta divided by pi2. I'm going back to the like spiral and plus, and then R. So it should be darker in the center, brighter to the outside, from red all the way to green.
Yeah.
Which is,
some nice fall colors too.
Okay, so then if we were doing the, like this relative to this, like not, so I'm trying to figure out how do we properly compare the current R theta of the pixel to a current spot, like in the sort of Phyllotaxis pattern. I mean, in theory, what we like.
I just want to try something.
Yeah.
Because I don't see time at all. Where's time?
Oh, I'm not using it right now.
Oh, right. That's why. True, you had the pi too. Oh, wait.
What does fract do?
He's not using A. Yeah, he's not using A. I think you'd have to put the A somewhere.
Yeah, no, it's fine. I was gonna wait.
Okay.
Yeah, no, I don't know what I was just poking around to try to understand things, but I don't really have a solution for. Ooh, I like that.
It seems that it's like tan. It's just Nicole suggested to use fract with time, which
that was for before when it was spinning. Yeah, to make it go all the way.
I was curious to see what happens.
Oh, because it was it's an integer? Like what does fract do?
Yeah, fract divides everything up into like it's like fractions out the.
Is the fractional part of the argument inside?
So color. Oh wait, what happened to R here? I wanted to have R. There, that's what I was. Okay, got it. So we see a sort of spiral here because the brightness is getting of the red is, and this would be more obvious if I do this even. I think, maybe not. So there is kind of like a spiral pattern here. The interesting thing to figure out is, well, I kind of, in a way.
Yeah, I wonder what's in your head. You probably need the
You
floating
need a
number.
dot.
Yeah, I'm understanding how this is working. I'm trying to
Oh,
think.
so
What I'm
pretty,
trying
the
to think
colors.
about is like the Phyllotaxis pattern is an iterative one. So the way that we can compute it is with a for loop, but that's what we were doing before. Or we could use the time value to like look at each particular spot.
Because iterative.
And so we have, this would be the Phyllotaxis radius. And then where did I put that angle? And this would be like if Phyllotaxis theta, like if I just for a second, I forgot that this was in here. Like just simplify things for a second. And this is the polar, like we have our, so let me just take this out for a second. We have the actual r and theta of any given pixel, which is these two values. Then we have an r and theta for like the given iteration of the Phyllotaxis pattern according to time. So in theory, we should be able to compare these two values in some interesting way.
Ooh.
To see, so like how do I do modulus?
MOD. I was about to suggest it. Yeah.
Yeah.
Mod.
So
To
I
me,
could
like
just
that's
do
the best way to compare the two.
modulus. So like no, it's not.
And then it's like a vector 2.
You can't use like the percent sign. That's not modulus.
No, it's just like mod, like
Function.
And 2 arguments.
So
mod here, like that. Yeah.
So MR. So if I said modulus R plus, and then the thing that I want to modulus with goes in the second argument.
2 arguments. Compute. Yeah.
And then the modulus theta equals and then color would be
M theta. Oh, okay. Ooh. Ooh.
Like a clock.
It's interesting. I love the colors.
Yeah, for me, it blows my mind. Your math in order to achieve this.
But why are I'm trying to see the I wonder if the Phyllotaxis pattern is in there and it's just such a smooth gradient that I'm not really seeing it.
Ooh.
Modulus
we
R
need to
plus.
step it, you mean?
Well, not. I don't know. So like, is this anything more than just a rotating spiral of color? Is the Phyllotaxis pattern sort of in there somewhere?
I doubt it because we haven't like stated the amount of like dots, right? So, or you would.
Well, what I'm doing is trying to reveal the Phyllotaxis pattern
Yeah.
as like relative colors for every pixel.
Okay.
Yeah.
Yeah, might be that it's there then. that is a good question, but I don't know.
Let's
Someone said, would the solution be to just over-rotate space? I don't know what that means, but if that means anything to you guys. Ooh. What if we stepped the drawing of this pattern?
Hold on, I was.
You're missing one argument at the end.
Shader. There's a section. I'm gonna look something up in the book of shaders because it's like a whole section on patterns.
Yeah.
I
love the
I do
effect,
like
by
what
the
we
way.
got.
I love the shader effect that we got right now anyway, even if it's
then
not Phyllotaxis.
there's so much like crazy stuff we could do now with like sine and
yeah, exactly, not necessarily the dots, but I wonder. Yeah, go on. And me, what if I'm gonna frag the UV inside the just, this has nothing to do to trying to make, I'm just trying to see what happens when we, oh, I broke. Why? Did I broke it myself? Oh no, something else is broken. What is it? Let's see.
Oh, I was mucking around. Oh, whoops. There, sorry.
What?
How
What
did-
was that? Oh, it
one
was
more.
no.
I was
this
trying to
was-
just separate out the RGB values.
Yeah, that's fine. RGB.
The
Let's
separate
see.
variables.
R and G is R is MR. And what is G? I cannot read it because your name is there. Maybe in there we had
Oh, m theta divided by pi.
divided by pi. So, and why
Hold
is
on.
it broken?
No, something else is wrong because
I don't think it's the space that I put here.
yeah.
Why I don't see it anymore? Did we move something else? Oh, I'm gonna look in the console because now I don't know what we broke. I don't see it with my eyes. Do you see if we edit something else? Oh, maybe I need to reload.
Whoops.
I reloaded, so.
Oh, okay.
Huh? Let's see, where did we break it? Invalid R. Hold on, there was something in the console about R being
Oh, I know what it is. I'm so silly.
broken.
I'm
it's
using
two
R
Rs,
for radius
two
and
Rs,
for the
two
red,
Rs.
red value.
Yes. Yeah. Yeah, now go for it again. Yeah. Now it should work.
Okay.
Yay! Yeah, debugging shader sometimes, but actually looking at the console sometimes works because I saw it there. So. And now I'm gonna go back to try to fract the UV as I just to play with you.
I made it do
I
something.
was trying to. So maybe we need to fract.
What are you trying to do with R?
I was
Ooh.
trying to, because we needed like this kind of like more than one dot anyway. So, and I was trying to find a usage to show you what frac does, which is a fraction in the space, so that when you want to do patterns is very useful.
Ah, I see.
So, because you can move this number, and if you would increase it, then you see more of whatever you're fractioning in there.
I love it. It's like a trippy bullseye. I think that if we actually want to do it without a for loop, the dot thing, I think we'd have to use a matrix thing.
Ooh.
I think that
I've lost sight of that and I'm just playing
Yeah.
with it now.
No, I know. I
Me
just
too.
was looking. I was looking on at the book of shaders to see, but I think that would be
Okay.
the ideal way to do
maybe
it.
it's not as easy as we expected it, because yeah. But it was interesting to try to tackle it.
Is it constantly starting over, or is it just that the
That's only, yeah, if I click into the, oh, it is
I
starting
think it's
over.
because you're using sine here, isn't it? So
Yeah.
it's kind of like
Oh, I
bouncing back
didn't. Oh, let me just go back to this.
Ooh.
Oh yeah, it's the modulus that. Why does it? Yeah, it's like. Yeah.
Is it because sine or what? What is your wonder?
Well, let me just go back to this. I was trying to get it to just go for. There we go. Okay. Yeah, I think
Now
the
it's
sine was.
confused.
Yeah. Okay.
Yeah, because the sine kind of goes back and forth. So whatever it was doing, it was always like not fully making the
Right.
the
Oh, this
the
is where I
circle
would need to
around,
put sine. This is what I was trying to do.
I wonder what effect are you trying to?
Well, I was trying. I was. I don't know
Still-
what I was doing. I was going to have the radius itself like shrink in and out.
Okay. Actually,
But
I
that's
see it now.
that's probably like
It's
like
growing. It needs to be a floating number, the 10. Just 10.0. We need a video like your whoops, we're floating number, floating
Yeah.
number, floating. It seems that
Yeah,
maybe
this is
it's
what I was trying to do.
Yeah, okay.
Okay, there we go.
Nice. I love this because this is the kind of stuff that actually when we do shaders, we're like trying to do some psychedelic
Okay, there we go.
visuals.
Yeah.
I love it. I love that
Okay,
it's
I
also.
can stop now. It should go back. The
Yeah,
sine
at
wave
some
should.
point. At some point, right? So, but maybe
Yeah.
since it's 100, so it's gonna go really, really deep. Yeah, now it's coming back.
I love the colors.
Yeah, me too.
Yeah.
It's like holographic a little bit, no?
Totally. Okay, Nicole in the chat, side note, pointed out that in the Book of Shader's Pixel Spirit deck, there is a pattern.
Oh my god! How?
You can see it?
Yes.
Yeah, so
Do you
the
see
way
that,
that-
Dan?
And then
Yes.
it's
That's
doable.
exactly what we want.
It'll only be in focus on my forehead, I'm sorry. Yeah, and so it uses ATAN.
So
There's
we were
also
going the-
fract, and there's also radians. So yeah, but I don't
There
know
we
if you
go.
if
Can
you
you
want.
show the code in the camera and then we like I guess it has to be much closer.
No, it won't
it's so
focus.
small.
I don't know.
Yeah.
But it's available on the GitHub repo of these cards. So if people are curious, they can find it.
Cool.
But yeah, it would require starting over from scratch, so I'm not gonna do it now. But I'll send you a picture of it later, Dan, so you can see
Okay.
if you're curious.
Yes. I am.
Ooh, I really love this animation a lot.
Yeah, I wonder if
So I
somebody
can't
has
stop.
the...
Very doors
can't
of
stop
perception.
tweaking it.
Yeah.
It's so awesome.
Oh, I messed something up.
Yeah, I mean, I love that you're still having fun trying to figure it out, like
Yeah.
through this
There we go.
psychedelic.
That's really, I like that a lot. My favorite thing about doing 2D shaders is when they start to feel like 3D because of the way the gradients play
Right.
around with each other.
Yeah.
It's so much fun.
This reminds me of a
Oh,
fan, an actual
I
fan.
kind of
You know,
see a flower
circles.
in there.
Yeah. Well, no. There might be actually something. I was
With
gonna say, I
the
don't
way
think
that the waves go, it kind of does a flower vibe for me.
Yeah, I think if
Ooh. Yeah,
This
very doors
were
of perception.
we have a weird sort of idea here. Use our special.
Oh, the radiance. No.
This is the last change I'm going to make. There we go. It's that weird.
Nice. It's better because the other one was a little bit more like
Yeah.
DC, and this is more mellow. I would say more chill to watch. Because the other one was too much.
Do you guys get the double layer of waves, or is it just my computer? Because I'm definitely getting like a floral pattern on top. So you have the like spiral, and then you've got the kind of lines, and then the more it goes backwards, I see these like other like a sine kind of wave. But
what's the resolution? Maybe it's the resolution of your screen. I have a normal monitor, like just I would say
I don't know.
Mine is HD.
Okay. Yeah, maybe it's my screen.
So maybe it's the resolution of the screen, I assume. So, because I don't see anything, this flower pattern that you mentioned.
I love it though. Awesome.
Yay. Yeah.
I'm just going to point out that it's been 2 hours, and I want to be respectful of Dan's time and his weekend. And maybe, I know you're taking care of your kids too, so I don't want to take you away from them all day. But yeah.
Yeah, no, I probably should get back to them and see if they need to eat some more.
Yeah, I was thinking about it, because I was like, for sure it's lunchtime, right?
2 hours of Minecraft is probably a good amount of time for them as well.
Yeah.
So yeah, but this, I mean, my mind is like, there's two things going on right now. All this, I think like my brain has emptied, so I can't even put words together anymore. Because it's also like my brain is exploded with all these possibilities, and I really want to look at. I want to understand. I want to understand this way of doing the Phyllotaxis pattern without the for loop. So I definitely want to look at that.
I'm going to send you.
Deck.
I'll take a picture of. Do you have the deck?
I have it. I think actually in. I have it in Brooklyn at NYU, so I don't have it on me. But
if somebody finds the link, because you said there's a GitHub repo.
There's a repo for each card, but I'll take a picture of the cards anyways that you need for the pattern, just in case it bugs you this weekend, so that you have it, and I'll send it to you on Discord.
If somebody has the link and they can put it on the chat, so because
I'm sure if Mario is still here, he will do it.
Is curious. Because I fear I'm still curious too myself, so probably I'm gonna poke at it on my free time, like how to do the Phyllotaxis without the loop, because so far
I was definitely there. Oh, thank you, Nicole and Mario. They both are on top of it. It is it's card 45, and then all of the dependencies are 19, 17, 9, and 4. 19, 17, 9, and 4. Yeah.
Wild.
Thank you. Anyway, thank you so much, Dan.
Thank you so much for having me. I've been sort of like tuning in and out and following your stream like last year. So it's an honor and super fun to be here. I really this is, it's just amazing to me, like how much more I understand now about shaders.
Oh, yay.
So I'm going to save this code pen and continue to explore it, but hopefully we can keep in touch and iterate on this a little bit more.
It was great. It was great to have you. We're happy to have you again anytime, and we'll be glad to see you maybe one day you want to try.
Oh my goodness, today Coding Train does shaders. I will
exactly. Yes. Maybe you will get started and
shaders and P5.
Awesome.
Yeah.
No, thank you for kicking off the second season with us. And like I said before, it's like for all the time that you spent teaching all of us so much, it was the least we could do to introduce you to shaders. And so fun, because it's my favorite thing. So
yeah. Well, if I manage to stream this Monday, which is my plan, I will at a minimum pull up this code and poke around with it and talk about it. So, and reference your stream. So that this is like your kickoff. So people, if they want to, they can continue. It's typically Saturdays on Twitch, and they can, do the fancy Twitch things to learn when it's coming.
Yeah,
awesome.
This season, though, we might not stream every Saturday. It's gonna depend, because sometimes some of our guests could be that if they cannot make it or we cannot make it.
We try to be.
But exactly, we're gonna try Saturdays, but it could be that sometimes it's gonna be another day. So.
We always yell it out on the socials anyway. So
perfect. Yeah, I'm very familiar with I stream on this day most of the time, but not every
most of the time with the asterisks always. Yeah.
It's just that sometimes life
And-
happens, and you don't want to like say, "Oh, I will not stream now," so then you can just
No.
move it to another day, right? So
Yeah.
And the fact that missing a dot is part of shader programming makes it fit perfectly with my whole.
It is. It's on theme. It's on theme.
It's on
Yeah.
brand, on theme. Yeah, cool.
yeah.
All right.
Awesome. All right. Well,
Yeah.
have a wonderful rest of your Saturday, Dan.
Thank you so much.
And thank
You
you to
too.
everyone
I
who-
loved
Thanks
being
everybody.
here. Thank you to
By the
everybody
way,
in
exactly.
the chat.
Thank you for everybody who came and stopped by at this time to watch us together with Dan. And we look forward to meet you. I think
Yeah.
so far we're gonna have our next stream. We know on November 6th. Should we announce the guest or not yet?
Yeah, go for it. No, you can if
Yeah?
you want.
Yeah.
Yeah. Yeah.
So our guest for the following stream, everybody, is gonna be the wonderful that I don't know if you're still here.
She's still here.
Yeah, Char Styles, who
Yeah.
was
Oh wow.
our first
Yeah.
guest in our
True.
Curiously Minded, like the
First.
first ever episode from season
Yeah.
1. She was the very first guest that we had. So we figured it would be an honor to just have her back at us and maybe poke Ray Marching together with her, which she's doing
Yay.
fantastically. So yeah.
Shader, you're going from shader beginner to shader expert.
Yeah, and then we find ourselves in the middle somewhere after that. Yeah.
Exactly.
Exactly.
Exactly. So yeah, lovely to have you, Dan. Thank you so much.
Thank you.
And
right.
anything else you want to say before we go?
No, just thank you to both of you. I'm excited to see. I'm excited to hopefully try to tune into your next stream with Shar and keep in touch
Yeah.
and make more fun shaders together.
Awesome.
Yeah.
All right. Thanks, everybody.
Okay.
Bye.
Bye.